In this video, we will be exploring model capturing by considering a real-world example to extend the existing system with as-built information from different data source types. So in the first example, we'll be looking at when you receive an as-built drawing in a PDF format. If we explore the information, we can see that we have some water pipes indicating where it will be connecting to the existing system and additional elements to add, like fire hydrants and valves. There's also an inset A for an extension connecting to another part of the existing system. We also have the legend to explain to us what we are needing to look at. So we're interested in the water, so all the blue lines. And also that for water, everything that we'll be capturing is in PVC class 12 and so forth. So the first step would be to know where this PDF will be going, or when you convert this to an image, to be able to import that into Wadiso, to know where to import it to. So if we consider the coordinates that we have available, we can see that the y is actually increasing. So if we consider this line, it's increasing in an easterly direction, because from the image the north arrow is pointing that way. So the y is increasing in easterly direction, or westerly direction rather, and also the x value is increasing in a southern direction, which means that this is actually the coordinate system we are seeing is the southern hemisphere coordinate system, with y increasing to the left or to the west, and south increasing, x increasing to the south. That information also is all important when you try and fix this to the correct location. So after converting that to an image, you'll be able to insert this bitmap. So the first thing that I just want to do is I know one of the coordinates, and I want to set my user coordinate system to the southern hemisphere for the CAD background to know the x and y values. So if I change this back to world, then we will see that at the bottom here, the x and the y have swapped around, and we now have negative signs. If I change this to the southern hemisphere, y and x are swapped, but both are positive. That's just an important thing when working with coordinate information from map data. So the first step that I want to do is I want to use one of the known coordinates just to orientate myself a little better. So I'm going to use this coordinate 14,301. And I'm going to put in a construction cross at that location. So here we can type, because we are in the southern hemisphere, we can type in the y and the x values. So 75, 600, just confirm. So 375 to 600, 375 to 600, 375. So we can see there's already a mistake, to 600. We're not interested in angles, we can keep that at 0. So here we can actually see what that location would be for in terms of this map. So now we can add a CAD layer just to ensure that we control where this image will be imported to, as it will be importing to the current layer. We can see which one is the current layer on the CAD layer manager, the item in bold. And I'm just going to move this as well just to the bottom, so other elements are drawn on top of it. Right. So this is now the active layer, so I can click on the insert bitmap item. Then I can browse to the location. In this case, my file is at type TIFF that I exported the PDF to. And click on open. And if you do not have known coordinates from a world geometry file, like for JPEG or JPW file, then you can select override and select the location where that needs to be imported to. From my construction, I know it is close in this proximity, so what I just want to do is I want to put it close. Right, and then I'm going to click OK. So as you can see, it now seems that nothing has been imported. However, if I right-click on the image, we can see something very small there, so we can zoom to selection, and there's my image. So because we are going to try and do a fixed coordinates from points on this map, it is a good idea to try and scale it to a more reasonable level, because every small pixel error will be incorrect when you try and transform it. So I'm going to select that, and then I'm going to choose the scale objects of the selection. I'm just going to choose the center point, and you can on the fly see how large it will be by moving it. In this case, it's very small, so I'm going to scale it by a 100 factor. Okay, so now we can see it's still very small, but it's more reasonable. I'm just going to scale it once again, just for ease of use, by another 2. Right. So now I'm ready to try and orientate my image with this coordinate at that known point that we know about, and then using one of the other construction crosses to reorientate and scale the drawing. So we select the items that we want to fix, go to CAD, Tools, Fix to Coordinates. Then with the arrow button, we can select what point on the image we want to reorientate. Just zooming in to ensure that we get as close as possible to the correct center. In these boxes, because we know what the coordinates are, we can type them in, 52600. You will also see the red arrow for the first box, and as we type in the second one, you'll see a blue arrow showing you where those points will be reoriented to. So for the second point, select, zoom in to be as accurate as possible, and then type in these coordinates. And again, the blue arrow showing, so this is how the picture will be changed. We can also do a preview. So on the preview, you can already see that the north arrow is now pointing to the expected north, or up in case of a world space. And again, if we have additional information like the boundaries that we have there, because this is a real world known example, we have those boundaries, we can turn those on, and then we can actually see that they do overlap quite well with what is in the image, so we can be happy that this reorientation is correct. And click the OK button. If you ever get a message like this, this is just an indication that the image that I have sized is very close to the real world. So this is if you choose yes, then the draw will only be fixed to the first point. So that first one we checked, and then just orientate it around or rotate it around, but the scale will remain unaltered. In this case, I scaled the image myself. There was no control over that. So I'm going to select no, that it does take those two known points and tries to scale it accordingly. Right, so now what we have is, I'm just going to take away the construction, it's in the way. Now we have a situation where we are cut off, we actually want to extend our existing system to, and that information is sitting on the detail. So what we can do is first capture what we know, and then go and alter the drawing afterwards. So as indicated, we know that all the water mains will be UPVC class 12, and we have information on the item itself of what the pipe size is. So to simply add these, we go to add pipe, and because we know what the materials, this is connected to a database with default types that is available. So if I choose material UPVC, we know it's UPVC 12. Okay. All that this will do is limit the options as we go along. And for the first pipes, we know it is 160 nominal diameter. We choose that, and we can see the green fields means that there's no other options. This is the only one in our database, those values, and we are going to choose this because there's no additional information on the map to override this information. What we also have available to us is integrity fields. So locality, integrity, and so forth, it's good to indicate where it's coming from. So we have some pre-populated keywords. So AB for as-built, because we are capturing this from an as-built image, we will select as-built. The locality as well. Year integrity, that's indicated on the as-built, so we will say as-built. Material, we are also happy with as-built. So depending on what type of information you have, you can set integrities within your model elements to know where improvements should be made in future, especially if you are capturing from design drawings which are not as-built yet. You can also enter the drawing number. This is a memo field. if we have the information available, we enter that as Z, so this will be added to all the pipes that we are capturing, and then the year information, if we look at the as-built, we can see that this was done in 2018, the last record drawing. And we can also, because it's as-built, we can set the fact that the pipe is actually true, the exists field. Right, so in terms of pipe capturing, dependent on, you have different types. You can have each click will actually put down a node and create a pipe, and then you have to start again at a new location, or you can have connected mode where you click and continue adding pipes with each click, having to right click to end, and the multi-segment mode is to allow vertices within the pipe if you do not want to place nodes at every bend. So for this example, I'm going to use the multi-segment mode. I'm going to start as mentioned here, and we can edit later on. So I'm going to click on known points. So I'm going to click just there. So you can see with the multi-segment mode, no node will be placed. However, if I change it to this type, I'm going to place it there to break the existing pipe. A node will be created, and now we do not continue because a new node has been inserted. So we have to start again. Just simply click on that node, and now you can see if I go along and I click there within the multi or the connected mode, each left click now will put down a node and allow me to continue. So for this example, I'm going to choose to add nodes at every bend. Here we have a T connection, so that will also be a node. And we can also see that from this point on, it's actually 110 millimeter pipes. So I want to continue only up until that point with my addition of 160s. I'm now going to right click to end the pipe addition. So there we have the existing system pipe captured. If we turn off the image, we can see that these pipes are now connected. I've inserted a node, and it's also attached all the geometry, so that we can see by if I move this node, all the connected pipes will move with it. Just going to turn back on the image. So for the additional information of 110 pipes, I will again choose there. Your last entries will be remembered. What you can do is you can reset all of the search, and I know UPVC 12 is correct, so I'm just going to tick that box. So when I do a reset, that value will not be cleared. And again, in terms of nominal diameter, we can search for 110 because we know that is the value. Again, all green, all of this information will stay the same. Again, I'm going to use the connected mode. So going along there, we have a bulk meter, so maybe a good idea to put in a node over there. Then we can see some bends in our pipe. So another T section. I'm going to choose to go into this direction first. Ending and just restarting. In this case, same information applies. Just zooming in, scrolling. Right click, start again. Right, so I've now captured all of my water main pipes on the main drawing as it's been oriented. Okay, so just going to turn this image off so we can see what we've captured. But apart from just the water pipes that we've added, there is also additional information like valves and hydrants. Those that information type is not a node or some other thing in Wadiso. We have an additional layer called appurtenances, which are model entities which are not related to the hydraulic model itself for performing the analyses. So all of these different types you can put on pipes and locations, so you know that that information is there. It is a water network asset, but it's not used within the analysis itself. So that's quite easy. What we can do, let's go to the first one, is we go to this one, which is add appurtenances. It's also found in model data manager appurtenances. There are a few options. So we are considering the valves now. We're going to select valve type. As you can see, there's quite a few. Select valve, and then just do a quick. Okay, start over. So choosing that, valve is selected. We want to insert our appurtenance onto the pipe layer. Appurtenances can be added onto any of the link layers, which is pumps, valves, and pipes. So we are going to, you can see there, it's right click to escape, or escape to cancel, so we will be in an addition mode as we go along. So I'm going to add valves. The valves will automatically be added as a snap to, so at the location you are entering it, and it will accept the pipe's rotation. So as we move along, you know that we have a valve over there, over here. In this case, we also have a fire hydrant. So as you are capturing, you can actually change the type before you end. You can see there, so we can change it back to a valve. This is a bulk meter. We want to indicate valve meter box. As we move along, we have another fire hydrant. We know that there are fire hydrants at the end, so I'm just going to put the fire hydrants all down. You will also see that even if I click a little bit off, the blue line is only displayed interactively if you are on a line to insert it on. So if I click off of the pipe, nothing will happen. It will only insert once I'm on the pipe, or it's indicated in blue. And check that, yeah, we have a fire hydrant at this end. Okay, I did not capture that stub, so that's why there's no pipe. That's something to add. In terms of the manual capturing, go back to valve. Seems that we have covered most of them. And as we now know that pipe wasn't captured, so we can simply go in. It will at least still remove the last 110 that we captured. Remember to place the node before we right click. That's why previously the pipe wasn't added. And then go back to appurtenances. Okay, there's a valve. And there's a hydrant. Type in H to find the first one. Right. What we do now know is that we need to sort out this portion over here, as that is not, this is the inset A, so we have to reorientate inset A. There are no coordinates specifically on inset A. However, we do have some boundaries that we can use, so I'm going to turn off on the cadastral. If we did not have that, we would have to put this locality integrity of this portion of the pipe as, for instance, a schematic or estimated, because we didn't have that information captured perfectly from the as-built. So I'm going to turn on the cadastral layer again. I'm going to use my drawing, just move it out so right, and now I want to try and orientate this inset part with known data. So we know that this valve portion is over there, so we can try and find a boundary close to that, a connection portion. So this boundary shape over there, we can see it happens there. So I'm going to use this point over there, CAD tools, fixed coordinates. I'm going to try and find a corner. So this side seems a bit better in terms of selecting the correct corner. Right. And then with this arrow, I'm going to point to this location. Okay, then we need to find along this little route a different one. It's always good to try and find a different or opposite end of the one corner. So I'm going to try and find something over there. Here we see double lines. We're not quite sure which one of these lines it would be. So let's look at just across it. Okay, so in this case, it's also just single line. So I'm going to choose that one. And find the corner, and that would be this one over here. Right, so again, with preview, it does reorientate. Now you can see detail A is over that. Click yes. Same question, I'm going to select to reorientate it anyway. So now this line, see, is a little bit off information, but now our valves are a bit better than previously. So this line has to be edited. So what I'm going to do is I'm going to move that vertex, which I placed earlier. And in this case, I can decide to have nodes or not, or I can say edit polyline, and then the insert, just to insert vertices across this line. So it's not an additional pipe, so I'm just changing this. So there we go. Turning off the image. We have our pipes. This one I'm happy with now. It's an as-built. We have our new node connecting to the system. We have our valve positions indicated, and so forth. As you would have seen, there is danger in the image type, because it can, in terms of printing or exporting to an image type, there can be data loss, or if it's not high DPI, which makes it difficult. It's also each pixel you click on, if it's not scaled big enough, you can have differences in offsets when capturing. So it's always better to have an actual CAD drawing that was generated, or the GIS data. So what we're going to look at now, I'm going to undo all my changes. And the second item that we're going to look at is actually if you received a DWG drawing. So what I'm going to do is, on a new drawing, I'm going to open the same drawing that was received in DWG format. Right, and then just making sure after loading that I zoom to the current selection. So again, you can see it's the same orientation as that we've had for the PDF in terms of the north arrow pointing. So we need to do that exactly the same, the fixed coordinates. Now we can see we have a few more items available. Because it's a CAD drawing, what I do have available is more snap settings, which I can turn on. So now we're snapping to cross points, so it's much better in terms of my click selection. So the first step would be to fix the coordinate. So if I just have a selection of, I'll just change to freeform. So if I just have a selection like that, I go to CAD Tools, Fix to Coordinates. This message will pop up, and only the selection will, or not message, the bar at the top will pop up, and only what I've selected will actually be transformed based on my click sets. If I just right click in, if you have nothing selected and you go to CAD Tools, Fix to Coordinates, you will get the notification that you have selected nothing. So your entire drawing, meaning all the CAD layers that are visible, will be fixed based on your clicks. All right. So in my case, I'm actually only interested in all the water files. So I could potentially turn off all the other layers by inspecting, what layers do I have available, which ones do I want to use or not. So in this case, I'm just going to quickly transform all of that. It's quite easy, and then I can turn off the layers. So I'm going to go CAD, Tools, Fix to Coordinates. I know I want to fix the entire drawing, so I'm clicking yes, because we're on a new drawing. There's no other entities over there, just the source CAD. Click yes. This case now I can click, I have some additional ones. I'm going to click nice snap point from the CAD. Again, we have to make sure that we are in the southern hemisphere if we want to use these as the Y and the X entries. So if I change to southern hemisphere, okay, just start this again, CAD tools, fixed coordinates. Right, now we can see we're in the Y and X has been swapped around. So very important to know which hemisphere you're in terms of how you want to use the coordinates. So select there, Y 14300, 3752700. Next point, let's choose the furthest one there, 14200, 3752500. Okay. Again, zoom to selection. Now we can see that we are reorientated. If we confirm this, that the snap on the bottom is basically the same at the different locations as we see at the bottom. All right. So now I actually also want to add on to my existing model. I have my model and GIS on this drawing, but not here. So I have different options. I can, because the model is already in Wadiso, I can go to model display and then decide I want to see this model actually on this CAD layer and apply those layers. So if I do that, it will generate that, and now we can see all my CAD layers. It's actually at the correct position. I can also reopen my GIS cadastral layer over here. The other option, of course, is to move only certain CAD layers over to the other drawing so I don't have all the additional layers which I'm not interested in. So what I'm going to do is I'm going to turn off the model display on this drawing, and then I'm going to select the CAD layers that I want to have, and I'm going to copy and paste those onto the other drawing, only those specific layers. So inspecting this information, what I want to transport, because I'm at the moment happy with the previous fixing two coordinates. We know that the cadastral is all fine, so I am not interested in anything except water. I want all the layers that have water. I've inspected this prior to this, and I know all the water layers are fine. That's what I want. And all of those have water contained in them, so I can do a wildcard search. We can see all of these, okay. But now I want to turn these on and the others off. So first of all, what I want to do is select all my layers, turn the visibility off, then again go back to my wildcard search. Sorry, hit the exit key there. Go back to my wildcard search, which selects all these layers, and I want to turn those on, and then I'm happy. Right, so now what I can say is, oh, I have a few green ones. That's stormwater, which makes sense because stormwater does contain the water keyword. But now I can do the same with storm. Select all of those and turn them off again. So now I have all my CAD layers, the correct orientation that I actually want to have to consider on this drawing. Only these are visible. What I can do now is on this space, hit Control A, which will select everything. Or if you really want to, you can make a selection like that. So Control A, right click, edit, copy, move to my original drawing world space, and over here I can say right click, edit, paste. You will see that the bar at the bottom is active and it wants you to move to. If I do not click on a different location, as you can see with the preview, it's trying to move it. If I only right click with not left clicking, it will accept the location that I've copied and pasted. And now we have, in terms of our CAD layers, we have our orientation, and we can do our manual capturing as we did for the PDF orientation. If you really wanted to, this is a small additional model, so that is obviously perfectly fine and well. The other option is to do a GIS import from the CAD. So what you can do is you can create GIS from the CAD to perform that import GIS into model, which is what we are going to do in this case. So I'm going to see that's water main. If I select all of them, those are the water pipes. And I'm going to quickly create GIS from these. I can either use current selection or specific layer. In this case, if I choose the layer water sea main, we can create that. It will automatically fill in a destination layer with the same name. We want polyline features. We don't have other information. You could add layer and color and so forth. We don't have that at the moment. So in this case, I'm just going to click OK. Right, so if I'm drop down, now we have a new GIS layer, field 1 automatically added with the correct polyline information. What we need to do now is, if we want to do a GIS import beyond just the geometry, we can fill data in that will be used in the data mapping when we're importing. So as previously we know that there's a material field. Right, of text type, we're going to add nominal diameter, we can call it that, and that is of a real type field. We have, for instance, year. Just for explanatory purposes, I'm going to call it this, and that's an integer value. All right. So now I've done this. Because this is a small data set, I know that the 160s, I can do a selection like that. I know all of these in terms of the CAD are 160s. Right, go to this layer, only these. So I know that this is specifically the 160s. So I can do that. All of them are UPVC 12. All of them are 2018. And I can select equal on the empties, and I know that these are 110s. So I can quickly set up a GIS dataset from the CAD with the known as-built information. And what I can do then is go to model data, manage models, merge into model, import from GIS. My source table is the one that I just created, the 4C water main. And then you will get a field mapping. So your source table's fields will be listed, and you can choose into which field in the model those should be imported to beyond the geometry, which is an automatic import. If you have matching field names that you have in the model, then those will automatically be chosen. So material is a field in the model and it's chosen. So nomdam, we can choose which field that is actually. And we can see that we do have a nominal diameter field. So let us choose nominal diameter. And for year, let's see if we have a year field, and we do. So we select year field. Click OK. Model import is done. Let's turn off just doing some checks. Okay, so just turning off the cadastral and the GIS I created, and let's turn off all our new CAD layers that we've added. Okay, just increase that. Right, so here we can see that the nominal diameter has been filled, but some default value has been added, which is the last pipe entry. So we're happy with that, except that we actually want the correct values. So what we can do is also select all of these. If that information that was created automatically was false from the last entry, you can select, and then we have the function under model tools to update. The same way you would capture a pipe from your catalog information, you can update selected pipes. It'll bring up this form. So in this case, we know all of that is correct. Reset, and it's the 160 in this case. And we can say update selected, and all of that information will be filled in. We all have the previous from my example of capturing the PDF is all filled in. And then for this selection over here for pipes, we can reset again and choose the 110. And then click update selected, and all of the information will be captured. Right, so now more information has been correctly populated. Again, with the CAD and GIS, you have all your valves, you can do that manually. However, the next step we can see here is that with the CAD or GIS import, there is no automatic cross point or crossing pipes that are inserted. But what you can do after the creation or importing from GIS is run certain topology functions. So we have a show remove of intersecting links so that you can go and inspect on those locations if in fact it should be matched or not. So intersecting links, you can either display it as a selection of your pipes or a new temporary layer will be created, and what is this indicating is that it will be a circle of size 10 for your indication. Tolerance as well for your crossing of 0.1, that's quite small, so it has to cross completely. So okay. So in this case, on the existing model, we already have 771 intersection points. Okay, so if you zoom out, because I've selected to have it display as this temporary points. So the thing is, not all crossing pipes are incorrect. So that is why we want display. So now we know this is the portion that we've imported. This is incorrect. I actually need to insert a node. Quite simply, we say insert or add a node, and it will, you can go there, get that crosshair, click, it will add a node. If I now just turn this off, if I select this node and I move it, you'll see all of them are in fact connected. So Control Z. Then of course the last step would be in terms of data that you receive is actually from GIS that's already been captured in the way. So somebody else in the GIS department had the PDFs or the CAD drawings and they converted that into their GIS system, and you want to add that onto your model. So what I'm going to display there is, let me just do not save changes. So I'm taking away those changes again. On a fresh drawing, just show this capture demo current. We know already by now that we are in this area. Right, so we have, for instance, information from GIS datasets that we want to capture, and we have information in a pipe layer and in a valve and hydrant and meter type layer. Data beforehand, so we can see that we have an install here, which is an integer type, drawing number, a material, and a nominal diameter. So this is the information available beyond the geometry to import into our model. Beyond this information, we need to ensure, because that's the only available information, what our current model settings is for default values. So we can go to model settings in the system tab. So if information is not supplied by either manual capturing or from the data we're importing, these values will be applied. So for this instance, I'm going to change this to a smaller value, so we know that we've imported these to 15. Right. Now we're going to import from GIS by going to manage models, merge into model, import from GIS. On the pipe layer we're importing, we're choosing our pipe layer as source. It will match the same field names as before that we've seen in the CAD drawing import. So for this thing, I'm going to choose drawing number, installation year, I'm selecting the year field. And then nominal diameter, I'm going to choose the nominal diameter field. Remembering that I'm not setting the specific diameter field in the model, so the default value will apply. Clicking OK, the model is imported. You can now turn off the GIS layer, and we can see that our pipes have been imported. The label is displayed as 160 diameter, so the labels on the rendering do extract from the nominal diameter field and the material field. We can see that our modeling diameter is 15. We can set these manually to a known value, or once again, we can select all of the 160s in our captured pipes, which we know is these ones, and we can actually do the update from selected catalog. So it starts off with 110, so let's rather than select all the 110s. It's going to be quicker. Update the selected ones, and then select all of these. Make sure the selection is correct. Resetting, and then choosing the 116 diameter, just to fill in automatically all the diameters and inside diameters, that we don't have to do all of that work ourselves. So we can click update selected, and now you can see the rendering colors are all as expected with our, close this box, with our information set correctly. So inside diameters are set, we can see year and drawing number and all our integrity fields as we've set them up as well. Okay. Next, what we want to do is we have information on valves and hydrants and bulk meter placements. So the information available we have here is type and drawing number. We have on the model data, we have an appurtenance import available. This will ask you for a source layer. Only oddity with this, there is no field mapping that occurs. So this symbol type field, we need the same name to actually apply this automatically. So what we can do in this case is we can, from our source data, we can actually rename the field and call it symbol type. Right, then we can go to model data, manage appurtenances, import appurtenances. We know it's sitting on this layer. We can click accept. In this case, I might want to consider copying data across from the pipes that's already been filled, like drawing number and so forth for matching fields. So let's click yes. And now we can see that we have hydrants. It's linked to the item it's been imported onto, to this code, and it's also transferred drawing number. So those are items with the same values, fields with the same values as the pipe. So we can see the fire hydrants and the valves, all that were on the source layer. Right, so again, to confirm that we've added all of them, we can maybe change this to a bit of a better display, all red. So that in terms of our source layer for GIS, we can see that all of our items have actually been imported. To highlight some additional functionality that is available, I've just created or edited the valve hydrant meters table a little bit, adding a few valve points over here which are not connected to the line, one that's far away, and also move these a little bit off. So we have in the GIS tools set, we have a snap point to line functionality that can be used to move those points. Before we get into that form, what I need to do is just add a field for the rotation as part of, which is a real type field. As part of the operation, it actually imports the rotation of the line that it's moving the point to. So if you want to have symbol displays that you have a rotation available. So to do that, if you have a data set that, like this, which can happen a lot if different people capture the GIS plans and there was an offset, or the information on the plan isn't that accurate and where the point is placed, which is a common occurrence, and this has to be on the line for importing. What you can do is then have the points layers. You can say GIS tools snap points to lines. This utility will ask you what the layer is on that you want to move to if you do not have a current selection active, which you can limit it to. So I want to update the valves hydrant meters shapefile. And then it asks you on what field to add that. I've just added the rotation field as example here. Then an important one is to have the maximum distance to consider for the line to be snapped. Outside of this distance, the line will not be snapped. I want to snap my XY position onto the line, so to actually move the line and the point. And then you also have an option of selecting the points that it could not snap. So you can see in terms of your layer or your selection, which were the ones that could not successfully snap based on your maximum distance setting, which I'm going to select now. If you click OK, it will tell you that 20 points matched and 1 point failed to match. And because I've had that checkbox on, it actually shows me the selection. So this was just done as an indication of how that option works. This is data that's not correct. So now we can see all these points that were slightly offset are now snapped onto the line. And that can be used for importing the data. As previously mentioned, the symbol type field needs to be active for a direct match, but for this example, I'm going to import and then use the spatial correlation function to update the type. So running manage models, import pertinences, valves and hydrants, clicking OK, selecting copy data. Therefore, once we zoom in, we will see, we just turn this off, just refresh the GIS. If we zoom in, we can see that these are not displayed. And the reason for that is that we did not have a specific type set. So these will all fall under the other values at the moment, which by default are turned off because they do not have a type. So in case that happens, we can now use the spatial correlation function because we know the type. So what we can do is from this data, because these are equal, we can do GIS tools spatial correlation. This will allow you, there are various different options. However, we know that these are one-to-one match, so we can say from the valves, hydrants, meters, from the field type, we want to import this into our pertinences, into the symbol type. We can use it a very small distance. We know they are very close to each other, on top of each other actually. So if we now click OK, we can now see that they've matched. There are obviously additional hydrants in the rest of the model that would not match. So now we can see it says fire hydrant type. These are valves, these are fire hydrants. So in terms of this example set that it should have been valves, but it was fire hydrants in terms of my data set. So if you know incorrect GIS, you can now also quite easily you can go and change that appurtenance type with all the availables. We know these are valves. So we can change multiple as well at the same time. So these are valves. And so those two special operations of snapping points that are offset that needs to be on the line. If you want to do importing with inserting information, we have spatial correlation, which is helpful in terms of matching data that's either close to each other, on top of each other. You can also do spatial correlation with the text labels themselves, as it does have a text correlation portion. There are numerous special functions in the CAD modify to allow you to do things. So in the case of the CAD drawing, if you have symbols that are polygons which you want to create into point data, you can extract those vertices. So I can open up quickly our source drawing, which in terms of the CAD to GIS would be very helpful when you want to import. So for instance, if we look at this drawing, we have all these valves, they are polygons, so I can select the entire layer. So all of those valves can be selected, and then I can say CAD, modify the geometry, and I want to extract the centroids as points. It'll actually extract that centroid, remembering that these CAD operations always set new or add new entities to the current layer, so it's always a good idea to add a new layer that you actually want to have control over. So all of these points are now on layer 0, so if I turn off everything except layer 0, turn them on again, we will see those points that were created for all the valve positions, which you can then use to create GIS and import that into your model. And then finally, as always, once you are happy with your model capturing additions, please remember to save the model, because if you close without saving, although you will get a notification, you'll have to redo all your work. Thank you.